Alright everybody, welcome back to another video. Today we are going to be classifying these critical points that we found in the previous video from this equation. So just remember we had that the gradient vector f of x, y is 3x squared minus 2y minus 2x plus 2y, and that the critical points occur when that equals 0, 0. Now, to actually classify these critical points, we need to find f sub x, which equals 6x. F sub y, which equals 2, and then f sub xy, which could also be written f sub yx because of Le Chatelier's principle, and that equals, let's have a little look, that is just going to be minus 2. Okay, so now let's actually take these critical points. So let's take the first one, 0, 0, which looks a little easier. So 0, 0. This is our first critical point that we're going to classify. We need to basically find the discriminant at this point, 0, 0. Okay, and recall, well, actually not recall, I haven't introduced it yet. I'll write it here. The discriminant at the critical point AB equals f of x, x at AB times f y at AB subtract f x y squared at AB. Okay, so at 0, 0, we're going to have the discriminant equals f of x, x, 0, 0, f of y, 0, 0, minus f x y squared, 0, 0. And let's just quickly compute this. So f of fxx is just 6x, so that's 0. So that's going to just go. And then we have f of xy is minus 2. Squared is 4. So we get this as negative 4. Okay. And, well, negative 4 is less than 0. Therefore, discriminant is less than 0, which means this is a saddle point at 0, 0. So that's the first one. We've classified the first one successfully. We've found that it's a saddle point. We are now going to do the same, but for the next one. Let me just get rid of this. Okay, let's change colors. When do we go to pink? So we're now gonna do. We're now gonna find the discriminant at this next point, 2/3, 2/3. So we got. So 6 times 2/3 is 4. And then we got fyy is just 2. Minus 2 squared, which is just minus 4. And that, my friend, is 4. Okay? So the discriminant is bigger than 0, which means it must be either a local max or a local min. We can say it's min or max. And we now need to do one more classification. We need to take fxx at 2/3, 2/3, which we already found to be 4. 4 is greater than 0. Therefore, we know that this has to be a min. And that's how you do it. Hopefully you enjoy this video, and I will see you next time.